this example, we're going to graph this rational function. We'll include its asymptotes and also its intercepts. So let's start with our asymptotes. And as always, wherever we have division by 0, we will have our vertical asymptote. So where can that happen? Well, how do we make 2x minus 3 equal to 0? We'll add 3 to both sides and we'll divide by 2. And that happens at 3 over 2, which of course is 1.5. So let's see if we can graph that. Okay, so don't be too unnerved by the decimal. This is 1.5. Okay, and the next thing, our horizontal asymptote, of course, as always, for a situation like this where we have a linear expression over a linear expression, both to the x to the power of 1, we just have to take a ratio of those x coefficients. So our horizontal asymptote is going to occur at y equals 4 over 2, which of course is y equals 2. Okay, so all that's left to do now is just plot a couple of points. And of course, since we're going to try to include our intercepts, we might as well do that. And that's probably going to look after most of the points that we have to plot. So let's find our y-intercept first, since that's always the easy one for functions. And to find a y-intercept, if we're on the y-axis, of course our x values would have to be 0. So what is the y value when x is 0? And if we sub in x equals 0, we don't have a whole lot of work to do. Since this is going to be 0 and this is going to be 0, we can see that our y-intercept, of course, is going to be negative 2/3. So let's include that in a different color. So that'll be approximately 2/3 of a box down. And there's one ordered pair. Now the next ordered pair I think we'll include, of course, is going to be our x-intercept. So we'll just scroll down here a little bit. Okay, and to find an x-intercept, that's usually a little bit more work. And of course, we're going to be on the x-axis, and any point on the x-axis has a y value of 0. So we have a little bit of algebra to do for this one. We have to figure out what x values are going to make this rational expression equal to 0. And right away, the trick to dealing with this is we can multiply both sides of this equation by 2x minus 3. And that cancels that denominator, and 0 times anything is still 0. Now keep in mind, the reason we can do that is because we know x can't be equal to 3 over 2. So we can't make that bottom equal to 0. So in this case, we can get rid of an expression with x in it, but it's no loss of information because that information that we are losing happens to be a domain restriction. So that just leaves us with the top. And in the future, all you really need to do is look at the numerator of your rational expression, and that's where you will find your x-intercepts. So easy peasy, 4x plus 2. How do we make that 0? Well, it's going to be negative 2 equals 4x, and we'll divide both sides by 4. And right here, we will write x equals negative 2 over 4, or of course, negative 1/2. Okay, so those are both of our intercepts, and all that's left to do now is just plot a couple of ordered pairs just by plugging in some x values. So just a very quick table of values. Of course, we don't have to sub in x equals 0 or determine what makes y equal 0. We already have that. So it probably makes sense to look at negative 2 to get some information about what's happening there. And try to avoid your your vertical asymptote, because that typically, the closer you get to that, of course, you're going to get ordered pairs that are well off your graph paper. So maybe we'll plot 3, and to be super keen, 4. So there's nothing fancy here. Plug in these x values. We'll get negative 8 plus 2, which is negative 6 on the top, divided by negative 4 minus 3, which is -7. So of course that's going to be positive 6/7. And I will just say that's a little bit less than +1 at x equals -2. So of course just be a little bit beneath 1 and we're good to go. And I think that's enough. Now let's just plug in a couple more x values here, and we'll put in 3, and we get 12 plus 2 on the top, which will be 14. And then in the denominator we'll get 6 minus 3, which is 3. Still a little bit awkward, but of course 3 goes into 14 4 times, so that's with a remainder of 2, so that's 4 2/3 for that y value. And that was at x equals 3, so we'll say 4 2/3. So one more x value. If x is 4, we get 16 plus 2, which is 18 in the numerator. And we get 8 minus 3 in the bottom. If we plug in x equals 4, 5 goes into 18 3 times with the remainder of 3. So this is 3 3/5, or approximately 3.6. Not approximately, exactly 3.6. So roughly here. So we have our second branch. And eventually that function will, of course, get closer to those asymptotes as we move off what we see in our graph paper here. Okay, so there's our graph. Of course, we've included the asymptotes. And the new information in this video, of course, was also including the 2 intercepts.